During the first period of development of satellites, the use of the data was really in the province of specialist users, the scientists who could really understand some of the complexities of the data. But with modern technology, the data are now going to become much more available and much more accessible to a much wider range of people, allowing everybody, including the citizens, students, school children, to make a real contribution to analysing the data and providing information to those who really want it. So this is opening a whole new vista of engagement with Earth observation from space, and that will increase even further the benefits of Earth observation to society.
Citizen science is an old idea. It's the idea that anyone can make a real contribution to science. And in its modern form, what that often means is sorting through the vast piles of data that we as modern scientists have access to. We've got very good about obtaining information about the universe or about the Earth. We have all of these satellites like the ones controlled from here, which beam down terabytes of data, but we're not very good at sorting through that to get at the knowledge that's contained within. We can use computers, but the human eye and the human brain and the human pattern recognition system are still unsurpassed. And so for many scientific tasks, all you need is lots of eyes on the data to try and make the really exciting discoveries. And at Zooniverse, what we try and do is take a large crowd of people and connect them with the images that will enable them to make those discoveries. I'm an astronomer, so we started with astronomy. We started with Galaxy Zoo, where people were classifying the shapes of galaxies. We've had people look at the surface of Mars to look at seasonal change, and we've had people discover planets around other stars. And in all of these experiments, we discovered that what people really care about is making a difference to science. It's not that the images are particularly beautiful. They're not. They're interesting, but they're not jaw-droppingly stunning. It's that people know that if they can do a little task, they actually get something real. And you can see that applied on Earth as well. People are willing to look at quite low resolution images to look at apparently obscure topics. Earth observation is exactly one of these areas of science that have too much data. And luckily, it's often perfectly suited for citizen science. The images are often inherently visual, and in particular when you're looking for changes on the Earth's surface, it's a task that people can easily engage in. One example is a project we run called Floating Forests, which is looking at enormous kelp forests off the coast of California. And kelp is particularly sensitive to changes in environment. So the kelp is a canary in the mine, a warning that climate change is happening, but it can be monitored from space if you have enough people to help you do the task. There's no point doing citizen science unless the data that you're producing is useful to actual scientists. That's what the public are doing it for, that's why we're involved as well. And so data validation is absolutely key to all of this. Luckily, we've got lots of people looking at each image, and we can put in a small amount of training data so we can assess the performance of the classifiers, just as you would if you wrote a new machine learning routine. That step's critically important, but that expertise can be shared between projects. And so if you solved it for galaxy classification, you've more or less solved the problem for keeping an eye on kelp as well.
Working with satellite data and with big meteorological model data requires a huge amount of computing power, and you can appreciate the scale of the problem and the challenge that Earth observations represent. Millions of satellite data are daily collected here and archived in this huge repository, and also meteorological data produced by ECMWF. This is in fact the largest data archive of meteorological data of the world. And we also need like a big storage facility to accommodate all this data and robots to operate the data archive.
If you're interested in climate change, you need every piece of data that you can get, and that goes for new data sets like satellite imagery of hurricanes and kelp and other ecosystems, as much as it does for historical data. We have a project called Old Weather, which is sorting through old naval logbooks, rescuing the weather observations contained within them and passing them on to climate scientists who are trying to predict the weather of the past. If you can predict the past, then you get confidence that we can understand what's going to happen in the future. The future of citizen science is, I think, bright, particularly for Earth observation. We've got a huge range of projects being proposed to us and to others, whether it's counting wildebeest from space or keeping an eye on the seasons as trees change colour. So there'll be lots more projects, but I think the projects will be more sophisticated as well. You'll see projects which encourage volunteers to go beyond just click work and encourage them to take a more active part in the in-depth scientific analysis. And I think you'll also see closer collaboration between humans and machines, projects networks which receive data from satellites and make an active decision about whether to give that data to a computer or to a particular human. And that sort of sophisticated analysis is what we need to be able to cope with the data that's coming in the next 10 years or so.